Hi guys, I just wanted to go over and make sure you understood the 4.1.2 information, writing polynomial equations from graphs. So let's go ahead and first, I know we did this in class so you can skip on ahead. For those of you that missed, I want to make sure you got this first part here. From this graph here, name the zeros. So that is easy enough to see. The zeros, or the roots, are where it crosses the x-axis. So let me make this a little bit smaller here. We have right here, which looks like it's -2, +1, and +3. So the zeros are -1, or -2, -2, +1, and +3. All right, create factors from the zeros. So that's the value that the x is. The zeros are the value that the x is. In order to create the factors from them, we need to make it 0. So our factors would be x minus, this is the x, so -2 minus what? -2 minus what would be 0. So it would be actually -2 plus +2. So the factor for that is going to be x. Remember, I'm not putting -2 there, I'm putting x plus 2. It's the opposite to get that factor. X minus 1 and x minus 3. Use the graph to determine the multiplicity. So that's a little bit trickier. The multiplicity is what is going to be the degree. What is going to be the degree of the graph. So, oops, I couldn't see the highlighter there. So let's take a look at this first one. I'm going to have to do something different than yellow because I can't see. There, green, I can see. So let's take a look at the x plus 2 factor here. It goes down, it touches, and then it comes back up. All right, well that's going to be an even one, and this looks like a parabola, so the multiplicity of the x plus 2 factor is going to be 2, like it was squared. Okay, the x minus 1 looks like the x cubed, right? It comes down, it gets a little bit flat, and then it keeps going down. And it's going different directions, so it's going to be odd. That's going to be cubed. And x minus 3 is going different directions here. So it's also going to be odd, but this looks just like a straight linear kind of relationship. So that's just going to be the multiplicity is going to just be 1. The multiplicity is the degree of that factor right there, that 0. Okay, and then it says, and this is where I heard a lot of questions, use the graph to use the 0.03 to determine the coefficient. So what it's saying here is if I input a 3 where my x is, my output, or a 0, I'm sorry, where my x is, my output needs to be a 3. So let's input 0 here with the multiplicity. So if I have y equals, instead of x plus 2, I'm going to do 0 plus 2. And don't forget that's squared. And then I'm going to do x, 0 minus 1, and that is cubed. That's important there because it'll give us a negative. Then I'm going to have 0 minus 3 to the first power. So this is going to be 0 plus 2 is 2. 2 squared is 4 times 0 minus 1 is -1. -1 cubed is going to be still -1. And then the last one, 0 minus 3 is -3 to the first power is just -3. So we have 2 negatives, so that's going to be a positive, that's going to be a positive. So we basically have 4 times 1 times 3, which is 12. So what happened here without a coefficient is I entered 0, but I got 3 back. Or I got 12 back, but what I wanted was 3. So the question is, what can I multiply x by that will give me 3 instead of 12? And I just have this little mini equation. So if I divide both sides by 12, I get x equals 3 divided by 12, what, 1/4? 0.25. Okay, so that's the coefficient. So the final equation is going to be, let's do an f of x. F of x equals 1/4 times x minus 1 cubed. I'm going to go with my highest degree first, times x plus 2 squared times x minus 3. Okay. Sorry if I'm sniffling, you guys. I have a little bit of a cold, I think. What are the key pieces needed to uniquely determine the equation of a polynomial? So just literally just those things that we talked about. The zeros, the multiplicity, the factors, and the coefficient. Although factors and zeros, you could say if you know one, you know the other. Factors, coefficients. Describe the steps needed to write a polynomial equation from a graph. Okay, you just need to restate what we just did. Okay, and I trust you can go back and do that on your own. All right, so we're going to do it again. If the zeros of a polynomial are x equals 4 and x equals 1, what are the factors of that polynomial? And that is, right, the opposites, right? X minus 4, because if x was 4, that would be 0. And x minus 1, because if x was 1, that would be 0. If each 0 has a multiplicity of 2, what is the factored form of the polynomial? So that just means each of what we just did. And then let's do this. X minus 4 squared times x minus 1 squared. If the polynomial passes through 2, 8, what is the coefficient? So if I input 2, my output should be 8. So let's see what happens without finding the coefficient. We just have 2 minus 4 squared times 2 minus 1 squared. So what we have so far is 2 minus 4 is negative 2 squared is positive 4 times 1. So we just have positive 4. So positive 4 times what will give me, what was my output supposed to be? 8. Well, 2. So my coefficient is 2. So my coefficient is 2. What is the polynomial in factored form? Okay, well, f of x equals my coefficient first, 2. And remember that coefficient's going to vertically stretch it or shrink it. So the 2 is going to make it stretched by, it's going to double it, right? It's going to make it 2 times taller. But the zeros won't change. 2 coefficient, x minus 4 squared times x minus 1 squared. So now that I have the equation, what is f of 3? Okay, so my input, all that means is what happens when my input is 3 minus 4 squared times 3 minus 1 squared. I'm doing this in my head, so please let me know if I make a mistake. 3 minus 1 is negative 1 squared is just positive 1. 3 minus 1, 2 squared is 4. So my output is 8. Okay, so f of 3 is equal to 8. All right, so now we're going to look at some complex numbers. And let's see how that works with them. So it's the same exact thing. If the zeros are I and negative I, and remember the definition of I is the square root of negative 1. So, but we'll just use I. So we have x minus I times x plus I. If it makes more sense, you could also do x minus the square root of negative 1 times x plus the square root of negative 1. We'll get the same answer. We will get the same answer anyway. So if each zero has a multiplicity of 1, it's just going to be exactly like I just wrote it. X minus I, x plus I. Use the descriptive property to find the standard form of the polynomial. Remember that I squared is equal to negative 1. So the distributive property, the way we've always done it in class, and you may do it differently, but the way we've done it in class is we use the area model. Okay, so we would say x minus I and x plus I and multiply this out. So we get x squared minus ix plus ix, and then here we would have negative, this is important, that negative, I squared. And so this and this cancels out, so what we have is x squared minus I squared. If you want really quickly, I can show you how you would use the distributive property for this. What you would do is you would break apart the first one. So you'd put x and negative I, and then you would multiply each of those times x plus I. Okay, and if you did that and then combined your like terms, you would get the same thing. Now, this is what it's saying. If I squared is equal to negative I, if I squared is equal to negative 1, then what we have is x squared minus, this is important to put this parenthesis here because this is the same as negative 1, and that negative make it actually x squared plus 1. Okay, so now we have an equation without any i's. So that's cool. If the polynomial passes through the point 3,5, input 3, output 5, what is the coefficient? So if I input 3 and I need my output to be 5, what happens? So this is how I do it, and then I'll show you how Ms. Stewart does it. It's a little bit differently. So what I do is I figure out what would I get if I input 3. I would get 3 squared plus 1. And 3 squared would be 9, plus 1 would be 10. So here, if I input 3, my output is 10, but I want 5, right? So what can I multiply 10 by that will give me 5 here? And that is what, half. So my coefficient is equal to half. Now, Ms. Stewart just starts it from the very beginning. She says, okay, I want to input 3, and I know I'm going to have to solve for some constant. So I'm just going to go ahead and put that there. I know some constant times x squared plus 1 is going to give me, she knows that that's going to be 5, right, if we input 3. So let's just input 3. So we'd fill it out so that the only variable we have is that k. And so what we're going to get is the same thing. 5 equals k times 10. Divide both sides by 10. You get k equals 1/2, right? So the same in either direction. So f of x, the final equation, is going to be 1/2 times x squared plus 1. Okay. And then what is f of 2? So then f of 2 would be 1/2 of 2 squared plus 1. Whoops, said 1, wrote 5 plus 1. Because that's going to be 5, is going to be half of 5, 2.5. Or I think Ms. Stewart's answer, she just leaves it as 5 over 2. Either way, you're going to have the correct answer. All right, I'm going to stop this now, start a new video because we're almost at time.